Okay, so in this question, we're asked to find the slope of the tangent line to the curve at the point 4, 2. And the equation we're given is negative 3x squared plus 1xy plus 2y cubed equals negative 24. So I guess the first step is to find the derivative of each individual term. And when we look at it, 3x squared and negative 24 are pretty simple. You just find it, you know? So it'll be negative 6x and 0. But since we're using implicit differentiation, which means we'll take the derivative of both sides of the equation with respect to x. Uh, for every y function, or anytime we take the derivative of a y term, we multiply it by dy dx. And so that's what I'm doing for 1xy and 2y cubed. So it'll be x times dy dx plus y, and it'll be 6y squared times dy dx. Okay, so the next step is to get the dy dx terms on one side and the non-dy dx terms on the other side. Um, and yeah, that's pretty simple. I guess if you put it on the other side of the equation, if it's a positive, you make it a negative. If it's a negative, you make it a positive. Pretty simple. And after that, you want to factor out the dy dx. So then there's x dy dx and there's 6y squared dy dx. So then you could just do dy dx times 6 plus I meant x plus 6y squared. And now you just want to isolate the dy dx by itself. So what you do is you get the x plus 6y squared, and you divide it by the other side. And that should be, I guess, your most like simplified derivative equation. So then now that you have this equation over here, I guess you just want to plug in the coordinates. So that'll be 4 and 2. And so for the x's, just put 4. For the y's, just put 2's. And it's just simple math now. This should be your answer. And I guess tips for future me. The first one is to use chain rule on any y term because whenever you differentiate something with a y, always multiply it by dy dx. And just plug in the coordinates after solving for dy dx.